This is inside the Reactor 1 building at the Fukushima Daiichi nuclear plant. Access is strictly limited due to high levels of radiation. In November 2013, our camera crew joined a team of investigators on a certain mission. They wanted to find out what's been happening inside the reactor building where the meltdowns occurred. Engineers created this small boat especially for the mission. It has an onboard camera to scan its surroundings. The boat ventures into an area with such high radiation, it's off limits to humans. The camera captures images of highly radioactive water that's become a major problem. It's the first visual confirmation of leaks from the reactor. Workers are still pumping large quantities of water into the reactor to cool the nuclear fuel that melted down. This water becomes tainted with radioactive materials. It's believed to be leaking out of the reactor, mixing with groundwater in the soil, and then seeping into the ocean. The plant's operator, Tokyo Electric Power Company, or TEPCO, has been unable to keep the toxic water from escaping. TEPCO has tried a number of measures to fix the problem, but tainted water continues to leak into a port attached to the plant.
Only readings of tritium are high. We're not quite sure why.
What's more, an extensive data analysis has raised the possibility that radioactive water is leaking from an...
We must pursue that.
Workers at Fukushima Daiichi are waging an unprecedented fight against radioactive water. On this program, we try to uncover the truth about this hidden crisis.
Nearly 3 years after the nuclear meltdowns at Fukushima Daiichi, workers began removing spent fuel from Reactor 4. TEPCO has finally taken the first step toward decommissioning the plant, a process that could take up to 40 years to finish. The meltdowns led to a serious problem that workers must still contend with today: the presence of water contaminated with radioactive substances. In July 2013, investigators realized that tainted water was draining unchecked into the ocean. The discovery of additional leaks since then has worried local residents and drawn international criticism. The source of the contamination is nuclear fuel inside the reactor's containment vessel. Take a look at this. The nuclear fuel was originally here, inside the reactor. After the core melted down, some of the fuel is believed to have penetrated the reactor shell and reached the bottom of the containment vessel. The fuel is still emitting heat. That's why water is being pumped in to cool it down. Water exposed to radioactive materials gets contaminated. It then leaks from the damaged containment vessel and accumulates inside the reactor building. And something is making matters worse: groundwater flowing in from the mountainside. The groundwater leads to more radioactive water accumulating inside the building. The volume increases by about 400 tons every single day. There are now about 1,000 tanks at the plant for holding tainted water. But workers have detected a series of leaks in the tanks, underscoring the potential risks. Groundwater flowing under and around the reactor building is another problem. It seems to mix with radioactive water leaking into the soil and then drains into the ocean. Fixing the problem would require locating the damaged areas of the containment vessel and sealing them. But so far, no one has figured out exactly where the damage is. We accompanied investigators searching to find out.
What must be done to locate cracks in the containment vessel? Immediately after the disaster, investigators began looking for the answer as part of a government project. A team including engineers from Hitachi GE, Kyushu Institute of Technology, and the University of Tokyo has developed this small boat equipped with a camera. Wireless communications can't be used under high levels of radiation, so engineers developed a special wire to remotely control the boat. Investigators will use this boat to search for cracks in the containment vessel.
Our first task is to find out where the contaminated water is leaking from. That will give us some idea of the kind of repairs and so on that need to be done. Locating the damage is really very important.
Every day, 370 tons of water are pumped into the reactor to cool down the melted nuclear fuel. That water is escaping from the bottom of the reactor, which was damaged in the accident, and flowing into the containment vessel. There's more. The tainted water has even breached the containment vessel, the last line of defense for containing the radiation. It's flooded the floor of the building. But so far, investigators have been unable to determine exactly where the water is leaking from. The main part of the vessel is surrounded by a thick layer of concrete. Contaminated water is accumulating around it. High levels of radiation prevent people from going near. So, investigators plan to place the remote-controlled boat in the water from a distance. They would then search for leaks, as far as the camera could see. Investigators suspected that large ducts extending from the containment vessel were the source of the leaks. They decided to focus on them. To prepare, they made a life-sized replica of part of the containment vessel. They used it to practice guiding the boat again and again. The boat's operators must work accurately and speedily to minimize the amount of time they spend at the site. This is footage taken around another containment vessel of the same type. The area surrounding the place where the boat will be inserted is crowded with intertwining ducts, paths, and other obstacles. To clear them, investigators need to drop the boat through this gap. It's just 50 centimeters wide. The project has cost more than $3 million. The team needed to do a lot of preparation before they attempted the actual investigation. In mid-November 2013, investigators entered the building housing Reactor 1. The structure is normally off-limits because of high radiation. They were finally about to begin. Even here, outside the concrete shield of the containment vessel, the radiation measures 5 millisieverts per hour. The team members who will position the boat can stay for just 15 minutes. Operators will remotely control the boat from a room on the second floor. To keep radiation exposure to a minimum, more than 20 workers will take turns. Still, the people overseeing the project decided that the operation shouldn't continue for more than 5 hours. From this point on, investigators will move the boat by remote control. Suddenly, there's a problem. The operator is having trouble guiding the boat through the gap. It's narrower than team members had thought.
Our time there was limited. It's not a place we could return to again and again. We were under stress until the very end.
The investigators have had plenty of practice. They managed to work around the problem. The boat is finally in the water. It begins to move forward. The boat's camera recorded these images. The white dots flickering across the screen were caused by radiation. The radiation here measures 2 sieverts per hour. That's enough to kill a person in just over 3 hours. Then, the camera captures water rushing down the wall. This is the contaminated water. The operator points the camera up to try to locate any cracks, but none are visible. The tainted water was videotaped right under one of the ducts that are a focus of the investigation. The duct is connected to the containment vessel. The camera also spotted another leak. This is the concrete shield that surrounds the containment vessel. Contaminated water is gushing out from a fractured pipe. More than 2.5 years after the meltdowns, investigators had finally captured evidence of leaks from the containment vessel. But the leaks may not be limited to these 2 locations. Investigators have yet to scan spots missed by the camera and those that are underwater. What do the results of the investigation tell us? We asked experts to analyze the video. They focused on the fractured pipe, the source of the second leak. Hiroshi Miyano is an expert on the construction of nuclear plants.
It's significant that water is leaking from the sand cushion drain pipe. That's a major problem.
Sand cushion drain pipes are installed around the containment vessel. They're designed to collect and drain condensation that accumulates between the vessel and the concrete shield. Miyano says under normal conditions, water would never flow out so vigorously.
Given the amount, it's hard to imagine that it all comes from the condensation formed here. There must be an opening somewhere. It's a very difficult problem. The containment vessel itself must be compromised.
Miyano says the probable location of the leak will make fixing the problem difficult. It's thought to be near the point where the pipe is attached to the vessel, but the only way to see for sure is to access the space between the vessel and the concrete. The gap is just 5 centimeters wide.
It's very challenging. Locating the leak will depend on whether a robot can be developed to do the job.
Hajime Asama is an expert on robots and one of the developers of the remote-controlled boat. He says high levels of radiation are another hurdle.
In one respect, gaining access through this gap will be extremely tough. Today, in medicine and other fields, endoscopes are used to look deep inside things through a narrow gap. But having a long enough reach and being able to withstand radiation are different issues.
One way to stop the leak would be to simply plug the pipe. But experts say that would only divert the water to other locations. The footage is a stark reminder of the seriousness of the situation. How long will the contamination continue? An expert who has analyzed the water offered an estimation based on the amounts of radioactive substances released so far.
Given the amount released to date, tritium will be emitted for more than 20 years at the least. Cesium will continue for even longer, another 40 or 50 years.
The water recirculates. Will contamination persist as long as the recirculation continues?
I think so.
What's TEPCO's reaction to the results? Vice President Zengo Aizawa supervises the company's nuclear business. The fact that some leaks have been located for the first time is a positive development, but Aizawa also understands how hard it will be to stop the flow of contaminated water.
Even if we found out where the water is coming from or leaking from, the question is how to stop it. I think it will be difficult, but we have no other choice. And if we failed, that would be miserable. We just have to succeed somehow.
The investigators began from square one and finally captured images of water leaking from the containment vessel, but they have yet to pinpoint the location of the damage. Given that crisis managers are still in the dark about the situation in reactors 2 and 3, it seems the road ahead will be tough. Even now, water is constantly being pumped into the containment vessel to cool down the nuclear fuel, creating more toxic water. The water then flows toward the turbine building next door and into underground utility tunnels called trenches on the side facing the ocean. TEPCO has maintained that it took measures after the accident to contain the contaminated water. It's true that in ocean water beyond the plant's port, tests show the amount of radioactive pollutants no longer exceeds the government's safety limit. But have a look at this chart. It shows the concentration of radioactive cesium in water inside the port. It dropped sharply at one point after the accident, but it has leveled off since 2012. At times, it has even exceeded the government's limit. This means that radioactive water is still draining into the sea. The question is how. Investigators suspect the source is these trenches near the ocean.
This is the entrance to a trench right near the sea. Inside, ducts and cables run everywhere. At the end is a wall that's shared with the building. There are gaps in the holes for ducts. In the buildings that house reactors 2 and 3, massive amounts of contaminated water have flowed into the trench through such gaps. It's thought that this is how tainted water is draining into the ocean. This theory is supported by data on radioactive cesium levels. Workers took measurements in monitoring wells in September and October 2013. High levels of cesium were recorded near the trenches and near the sea. But TEPCO says it began taking steps shortly after the accident to prevent any leaks. The problem began 1 month after the meltdowns. Workers discovered that massive amounts of contaminated water were flowing into the ocean through the trenches. They found that it contained extremely high levels of radioactive cesium, more than 20 million times the government's safety limit. TEPCO said it contained the leaks by cementing the trenches and taking other measures. But even today, radioactive cesium is detected in groundwater from nearby locations. This suggests that radioactive water is leaking from places missed by TEPCO and draining into the sea.
It's quite difficult to stop the contaminated water immediately. We'll have to deal with it over the long term.
What can be done to prevent the tainted water from flowing into the sea? TEPCO is under pressure to come up with a solution. Workers are creating a wall underground to block the toxic water from reaching the ocean. They're using a special solution called water glass. It solidifies in the soil, creating an underground dam. To block strong radiation from the contaminated groundwater, workers lay lead plates over the soil before getting to work. TEPCO initially built the underground dam along the shoreline. But it did not solve the problem. So the company is now extending the wall to enclose the entire area. Yet, 5 months after the work began, radiation levels inside the port show no sign of receding. And in some places, workers have found cesium levels that are higher than the government's limit.
The flow of contaminated water into the ocean is causing problems and worrying people. We are doing all we can to secure the needed resources and take the necessary measures as quickly as possible. But there are many challenges.
Why isn't the concentration of radioactive materials in the port going down? Is it due to the lingering effects of contamination that occurred after the accident? Or is it because newly contaminated water is flowing into the sea? And how effective are the measures that have been taken? There are many questions, but few answers. And now, concerns are growing over possible leaks from an area people had been worried about. Workers have found additional contamination from someplace beside the trenches.
The structure housing Reactor 1 is suspected to be a new source of leakage.
This is observation well 1T3. We installed it to check for contamination around the Reactor 1 building.
In September 2013, the level of radioactive tritium found in groundwater from this well exceeded the government's safety limit for the first time. The well is located on the ocean side of the Reactor 1 building.
We don't know the cause yet. The #1 subdrain pit is in that silver-colored building. The level of tritium alone is high there, too.
This well is closer to the Reactor 1 building. The tritium reading here was even higher.
We're having a hard time figuring out why, so we've dug additional observation wells.
Tritium was detected in 4 wells around the Reactor 1 building. Draw a line, and it appears tritium is flowing from the building toward the ocean. Why is the discovery of tritium significant? It suggests that the contamination could spread further. Tritium, strontium, and cesium have been found in the port adjacent to the nuclear plant. We did an experiment mixing colored liquids that represent the 3 radioactive materials. We inject our mock contaminated water into the groundwater and wait to see what happens. The mixture is initially a dark reddish purple, but gradually it separates into 3 different colors. Tritium, shown in orange, flows with the water. It's the first of the 3 liquids to reach the sea. Strontium and cesium are considered more harmful to the human body. They flow toward the ocean more slowly than tritium does. The detection of tritium suggests that the other radioactive materials may eventually seep into the ocean too. The Reactor 1 building is filled with 10,000 tons of highly radioactive water that leaked from the containment vessel. If that's the source of the leakage, the situation could become even more serious. Contaminated water could be flowing directly from the reactor building, not just from the trenches. But TEPCO officials have maintained that radioactive water would not leak, even if the reactor building had been damaged. That's because they removed some of the contaminated water with a pump and kept the level lower than the groundwater. We conducted another experiment to see how controlling the level of the radioactive water can prevent it from leaking. Let's assume the box represents the reactor building. It has holes in it on the premise that the accident in March 2011 damaged the structure. We inject black liquid as a substitute for radioactive water. If the level of the radioactive water is lower than that of the groundwater, there is no leakage from the holes. But once the level of the radioactive water inside the reactor building exceeds that of the groundwater, the black liquid starts seeping out. TEPCO officials figured that if they kept the level of contaminated water lower than the groundwater, the pressure difference would prevent it from leaking. But did it work? We performed our own analysis with help from experts. We focused on the relationship between the radioactive water and the level of the groundwater, which fluctuates. By comparing all the available data, we found that the water levels were reversed for more than 6 months following the accident.
The water level in the subdrain pit and the level in the reactor building were reversed by about 1 meter. Of course, if the levels are inverted, leaks become possible.
It's like the whole reactor building has been containing it. If something happens and the water leaks, there's little that can be done.
Let's look at groundwater levels at different locations. The data show the water levels vary significantly due to geological variations. It's not easy to contain radioactive water by controlling water levels. What's more, experts have shown how difficult it is to accurately grasp where contaminated water flows once it's leaked. Professor Hiroyuki Tosaka specializes in simulations of groundwater movement. He explored the flow of the radioactive water based on data about the reactor buildings obtained by NHK and geographical conditions. The blue area around the reactor buildings represents the groundwater. The arrows indicate the directions in which it flows. Let's assume that contaminated water, marked in red, has started leaking from the walls of the reactor building. Once it starts moving, the contaminated water flows to the left and then spreads in an arc toward the ocean. If we superimpose TEPCO's data on tritium levels over this image, they match. The simulation suggests that the radioactive water might have traveled along a complex route and flowed into the sea.
I doubt even experts could have imagined the contaminated water would move in such a way. At least I didn't. If a research plan was created based on this possibility, then I think it would shorten the amount of time needed to locate the source of contamination.
How widespread is the contamination around the reactor buildings? On this day, TEPCO Vice President Aizawa visits the plant for an inspection. In a well near the Reactor 1 building, workers detected tritium as well as cesium.
This is subdrain pit number 2.
Radiation at number 2 isn't high, right?
Right.
Not that high at number 2, but high at number 1 nearby. There could be some minor leaks occurring now and then. It doesn't take much for groundwater levels to change. They don't remain constant. We need to study that more and take the appropriate measures. There's no single solution that can stop the leaks right away. If necessary, we'll take some steps to improve the soil and ground conditions too. For the moment, we'll just have to dig more holes and check.
As the simulation indicated, it's difficult to get a clear picture of how contaminated water travels underground, out of sight. The reality is that many things remain a mystery. What has become clear is that it's very hard to control radioactive materials once they get into the environment. Given how difficult it is to assess what's really happening, are there effective ways to prevent leaks of radioactive water? Officials from the Japanese government and TEPCO are considering radical measures. One is trying to keep leaked radioactive water from spilling into the ocean. The other is to enclose the reactor buildings, which are filled with huge amounts of radioactive water.
Is there a way to prevent leaks from the reactor buildings themselves? Government officials are trying to find out. Koichi Noda is a director at the Industry Ministry who's stationed in Fukushima. His task is to find a way to contain the radioactive water. Government officials believe the most effective way to fight leaks is an ice wall. They're investing about $310 million into this massive project.
Have you decided on a location?
Yes, right here.
The underground ice wall will surround the buildings for reactors 1 through 4 and extend for 1.4 kilometers. The aim is to contain the radioactive water by freezing the soil to a depth where groundwater doesn't flow. A test began in December 2013 around Reactor 4 to check the effectiveness of the ice wall. No one has ever attempted to build anything like this before. It will take more than a year to complete.
What we're most concerned about is whether we can freeze the soil completely. We're conducting tests to make sure of that. It's important to proceed cautiously, taking one sure step at a time.
Hydroelectric dam is located on the Columbia River that supplies the power.
Is there an effective way to keep radioactive water from reaching the sea? TEPCO engineers visited the U.S. state of Washington. They went to see what's being done overseas to prevent leaks of radioactive water.
We are now down to slab on grade and completing a lot of the cleanup both above ground and below ground, which includes groundwater remediation. And
the Hanford site used to produce plutonium, a raw material for atomic bombs, including the one dropped on Nagasaki in 1945. The facility's underground tanks were full of radioactive water, a byproduct of plutonium production. A huge amount of radioactive water leaked from these tanks. The U.S. government has spent many years addressing the problem. Something in particular caught the attention of TEPCO engineers. It's a system for detecting contaminated water underground, which is difficult to do accurately.
You can see the line of the bars with the little orange caps. So that is a geophysical monitoring array.
The system sends electricity into the ground and uses sensors to detect contaminated water. It exploits the different electrical resistance levels of radioactive water and groundwater. This allows for real-time monitoring, 24 hours a day. U.S. engineers also developed new technology for decontaminating radioactive water. It removes strontium, a radioactive material also found at the Fukushima Daiichi plant. White lids line the riverbank. Underneath is a special solution containing calcium. In this solution, calcium is combined with phosphoric acid. Strontium has a strong tendency to combine with phosphoric acid. It replaces the calcium. This makes it possible to efficiently remove the radioactive material without stopping the flow of groundwater.
And then we have also designed the barrier to have enough calcium to be effective for a 300-year period. And this will also, with a 30-year half-life, approximately a 30-year half-life, right, gives you enough time for it to decay down to below standards.
Instead of completely blocking the water, this method lets it pass through a strontium barrier and flow into the river. I think it's an excellent idea.
But further research revealed that using this technology in Fukushima would be challenging. At this research facility, samples of contaminated water from the Fukushima Daiichi plant are stored under lock and key. They contain components of seawater. Right after the accident, fire engines were used to inject large amounts of seawater into the reactors to cool them. The seawater still remains in the contaminated water samples. Researchers have found that the U.S. technology isn't sufficient to remove strontium from radioactive water if matter from seawater is also present.
The radioactive water contains a kind of salt from seawater. It's similar to strontium and is measured at thousands of parts per million. The fact that the radioactive water contains this substance makes it extremely difficult to remove strontium just by adsorption alone.
Is it possible to decontaminate radioactive water that has seawater in it? Efforts continue to overcome a challenge unlike any the world has experienced before.
Each approach presents hurdles that must be tackled. At this point, there is no definitive solution. In October 2013, the government invited specialists from around the world to submit proposals for containing the radioactive water. Officials are now screening some 780 suggestions. The problem of water contamination in Fukushima isn't something that can be resolved through a single measure. A variety of steps is needed, along with the assumption that some may fail. There will be more radioactive water in the future. The crisis triggered by the meltdowns isn't over. Until the problem of contaminated water is resolved, workers won't be able to remove the molten nuclear fuel and decommission the damaged reactors. How can this challenge, unparalleled in human history, be conquered? Japan's resolve to face this seemingly endless battle is being put to the test.
The struggle against radioactive water continues at the Fukushima Daiichi plant with no end in sight. TEPCO is installing concrete walls around the reactor buildings. The walls are meant to protect workers from radiation. But just a few steps away,
450、520、540、550.
Are piles of highly radioactive debris. TEPCO is rushing to remove them so workers can keep battling the radioactive water. Every day, some 3,000 workers devote themselves to the cleanup. Half of them are local residents.
I know that we've come this far because many people have worked here despite the strong radiation levels. I really couldn't thank them more.
The path to decommissioning is a long one. Will it be possible to secure enough workers? This man has worked at Fukushima Daiichi for many years. His total radiation exposure already exceeds the safety limit set by the government. More and more people like him are unable to work at the nuclear plant.
Once you hit the limit, you can't work there. You can no longer use all the skills you've gained. It'll take 30 years to decommission the reactors, but you can't help. We need people to get the job done. Otherwise, we won't be able to go back home.
It will take decades to decommission the reactors. And contaminated water is making the job harder. The goal is clear, but figuring out how to get there is the problem.
421、570、670、570、670、600。